So I wanted to work through some examples of working with momentum, just to help you out with your practice set. So in the first case, we have a railroad car traveling at a speed and it hits another car that's at rest. And then they lock together, so we want to know the speed of the two cars afterwards. And so the general way to approach this is to draw a before and after picture. So we're going to do before and after. And then we'll put that straight into the impulse momentum principle, and then you just solve from there. So before we have two cars. So I'm going to assume that they're moving to the right, and so we'll call them car 1 and car 2. So you have this object 1. It's moving with some velocity in this direction. So that would be v1 naught. And then it strikes a second car, which is at rest. So v2 naught equals 0. And then they lock together, so that's before. So this comes, it hits it, and then they leave together. So afterwards, we have the two cars, 1 and 2. They're stuck together, and they're moving with some velocity final. Now, in this case, I'm just going to leave it as VF, but realize that the velocity 1 final, in this case, is equal to velocity 2 final. So they have the same velocity because they're together. All right. There's no external forces, so we're ignoring friction. So I can just make a note, no external force. We're going to ignore friction. And now we'll put it into our impulse momentum. And impulse momentum says that the total momentum, initial, I'll go ahead and put a sum on there, plus any impulse is equal to the final. So the total final momentum. And these are the momentum of all the pieces. So remember, this means add up and then our momentums. And so what we'll have is the momentum of 1 initial plus momentum 2 initial. So this is just adding up the two momentums. And then plus any impulse. Impulse would be any external force times delta t is equal to the total final. So the total final comes from this side. So again, we have 1 and 2. So we'll have the momentum of 1 final plus the momentum of 2 final. I'm writing everything out. We're going to cancel a bunch of stuff here in just a second. Okay, so now we can go back to our picture and we're going to think about what's going on. So momentum 1. Remember that momentum is mass times velocity. So momentum is equal to mass times velocity. So for momentum of 1, this one has velocity. So it's going to be mass 1 times v1 naught. And then momentum 2, well, momentum 2 has a 0 velocity. So the momentum is 0. And then plus any impulse. So there's no external force. We already said that. So there's no impulse is equal to afterwards. So afterwards we have mass 1 times VF. They have the same velocity. So I'm just going to use this instead of this. Those are equal to each other. Plus mass 2 is also moving. VF. Okay, so now we're going to solve. What we want VF. So I'm just going to put a little underline underneath it, and that's what I want. And now we'll start simplifying. So these are all 0, so I'll just pull this over. So we get mass 1 times v1 naught is equal to, both of these have a VF, so we can factor that out. So we get mass 1 plus mass 2 times VF. And I'm going to start skipping steps. I'm just writing everything out so you can see how it comes into play. Because this approach will always work. Sometimes you'll have force and time, so you'll have some value here. Sometimes you'll have two momentum, so it comes out here. But basically this part right here, if you always do that, you can't go wrong, including the picture. Okay, so at this point we're solving for VF, so we just divide the whole quantity over. So we'll get mass 1 times V1 naught divided by mass 1 plus mass 2. That's equal to the final velocity. I'm not going to do the numbers. You would just plug them in at this point. But that's our solution. So again, draw your pictures, set it up, and then work with whatever you have. Okay, so now we have a bullet fired from a gun, and we're going to want to find the recoil speed. So first thing, draw a picture. So before what we have is nothing's moving. So the bullet's in the gun. So we're going to have the bullet and the gun. I'm going to put the gun right next to it. And the whole velocity of this thing is 0. So for both is 0. And then afterwards, the bullet leaves with this speed right there. So we have the bullet is moving with velocity this way. So the velocity of the bullet final is equal to 230 meters per second. And then the gun has a recoil speed. So recoil means it goes in the opposite direction. So our gun is going to be moving backwards. And what we want to know is what's this final velocity of the gun. Okay. No external force that are acting on it. And then they give us the masses. Make sure the grams, you deal with that once you get the mass. Okay, so now we write our impulse momentum. So my total momentum, my total initial momentum plus any impulse is equal to the final momentum, total final momentum. What I want you to see is, like, you see how these all line up, and it makes it easy for me to figure out exactly what's going on without having to go back to the problem. So I have my momentums here, then my impulses, if there is any, and then my final momentum. So the picture corresponds to what I'm doing mathematically. So here, remember, momentum is mass times velocity. Neither of these is moving. So my total momentum in the system to begin with is going to be 0. And then there's no external forces, so I have an impulse of 0 is equal to my final momentum after. So in this case, we're going to have the final momentum of the gun. So the gun final plus the bullet. So the momentum of the bullet final. Okay, so what we can see is, let's go ahead and simplify. So we get 0 is equal to the total momentums. Momentum of the gun final plus momentum of the bullet final. And I'm going to want the velocity of the gun, which is in this one. So let's move this over. So we get negative momentum of the gun final is equal to the momentum of the bullet final. Now we can change some stuff. So we're going to have, can't drop this negative. So we're going to have the mass of the gun times the final velocity of the gun is equal to the mass of the bullet times the velocity of the bullet, the final. And we want the velocity of the gun, so we'll divide this over. So we get the velocity of the gun final is equal to the mass of the bullet times the bullet's velocity divided by negative mass of the gun. At this point, you would plug in numbers. So what's this negative do? Well, the negative makes the velocity of the gun negative. So that matches my position, my picture. So we're all good. Just remember that the mass of the bullet is 25 grams equals 0.025 kilograms. All right, let's do one more. Okay, so in this one, we're going to have two blocks moving towards each other. So block A is moving right, block B is moving left. They have the same mass, and we want to know the velocity after the collision. So let's draw it first. So block A is moving right, so we'll have block A. It's moving this way. And then block B is moving towards it, and it's moving left. So we're going to have momentum on both of these. This would be VA naught and VB naught. The masses are the same. Okay, so this is before, and then they collide and they stick together and they're moving. So we have A and B. Now, I don't know which way they're moving, so if they have the same mass, though, I guess we could figure that out. If block B is moving faster, so it's going to kind of win. So we expect it to be, I'm just going to draw it as like a little dotted line. I expect, this is my prediction, it's going to move this way. So that would be the velocity final. So no, they're together, so they're going to have the same velocity. So it was like in that previous one, VA final is equal to the B final. They're the same. So I'm just going to call them final. That's my final velocity. And that's what I want to find. There's no external forces, so there's no impulse. So our total momentum initial, let's see, plus any impulse is equal to the total final. And there's no impulse, so we just have the mass of A, and then VA naught, plus B, so mass of B, the VB naught. There's no impulse, so I'm not going to write it, so we can just cross that out. That's equal to my final. So my final, you can write it two ways. I could do the individual momentums, but I'm just going to do the momentum of both. So it'd be the mass of A plus the mass of B. And this comes up quite a bit. If we have objects that stick together, we just put their masses together, and that would be times VF. Okay, so we want VF, so just divide this over. I'm gonna flip it, or I'll just leave it. So mass of A, velocity of A naught plus mass B, B naught over mass of A plus mass B. That's going to be my final velocity. Okay, the only thing here you got to be careful with is like this is a negative velocity. So this would be -4. So I'm going to go ahead and just plug in some numbers to see. Mass A and B are the same. So let's see. So mass A and B, remember this, the mass is the same. So we can factor that out. So I get mass times VA naught is, I can't remember. It was 2, I think. 2 meters per second. Let me double check that. Yeah, 2. And then the other one is -4 meters per second. So we get 2 minus 4 over, remember the masses are the same, so that's 2m equals velocity final. So the m's cancel out. I get -2 on top divided by 2 would be -1 meter per second is my final velocity. If I did it all right. Yeah, 2, -4, that's -2 divided by 2. Yeah, we're good. So yes, it is going to move this way at -1. Anyway, this is just a general approach. So draw your picture, just like I did. Write the momentum impulse, just like I did. And then you just work with whatever you have. But there you go. That should help you get through the homework.